All right. Well, welcome everybody. This is the 7th of October, 2025, and this is Open Research Institute's projects meetup. And what we do is we talk about what we have done, what we have planned to do, if we have any roadblocks, and if we need any resources that ORI can help provide. And this is our roundtable section. So we're going to go around to all the folks that are here and then hear from them. And also, I'll read in any reports that I've gotten for folks that can't be here. I have a couple. And we'll lead off with Aaron. So, Aaron, you have the floor.
Thanks, Michelle. So I'm continuing making incremental progress in porting of the DVB-S2 encoder onto another platform utilizing OpenCPI. Last week, I reported that I had the ability to configure the register sets of the encoder, and I've been able to write the output of it to a file to do validation of the data by enabling the dummy frames from the PL frame generator, dummy frame generator, and you get the 90 symbols of the frame header, and then just constant one, I believe is QPSK or APSK. So the next thing I'm going to do, I was expecting a little bit different output, but I guess I hadn't dug too deep into it. So I was looking at the implementation, again, my reference implementation, and it looks like the input to the encoder is being driven so that it'll have valid BB frames or baseband frames, I believe that's what it means. So to generate null packets so that, because I plot the symbols and it didn't look as what I expected. So I think it's still valid and I think it's still synchronizable, but I wanted to see kind of a nice what we expect from the DVB-S2 encoder.
Right.
Yeah.
Okay.
So still plodding along. It's just incremental progress. So the next thing I'll be working on is feeding, getting the software, kind of generating the BB frames to feed into the encoder for the null packets, and then move on from there. So
Okay.
that's where I'm at right now.
Oh, very good. Thank you so much. Yeah, if you see anything confusing, then and if you have the time to explain it, please
Yeah.
reach out and we'll do all that we can to try to track it down, um, and help in any way we can.
Okay. Thank you.
You bet. No, anything else you need or any other?
Nope. I'm
Okay.
good. Thank you.
Yeah, thank you so much. And for those that are watching, Aaron is very much involved with a project called OpenCPI. And if you go to opencpi.org, you can see what this is all about. So very powerful project with lots of it is going to excite you if you're in this sort of work and you're looking at solutions and trying to deal with platforms and designs. So please check it out if you haven't already. Cool. Okay. And Thomas, welcome. And you have the floor if you have anything to share or say or anything that you need that we might be able to help with.
Hey, hello, good morning.
Hi there.
Um, uh, no, not really. I was mostly attending because you wanted to discuss the EVE
Yes.
2026, and but I don't have anything else to report or else.
Okay. Well, we will get to that as quickly as we can. We'll go ahead with the other roundtable reports about things that have been going on in the lab, and then we'll get into to talking about the things that we need to do to make this a successful thing happen in 2026. And so go ahead, Paul. You have the floor for anything that you might need to share with us. And there's been a lot going on.
Okay. Um, there has been a lot going on, but mostly in your court. I've been standing by with Dialogus. We got the streaming part back into its original working configuration. By working in this case, I mean that it just sends data bits and receives them. And in the in the loopback, the PRBS loopback case, that actually works in that we get the bits back and get 0-bit error rates, and that's great. We haven't made it back to that uh, state of grace while actually pushing data in and pulling data out. That's we still have some things to sort out on the FPGA side for that. And that does not include the timeline management improvements. Those we're on two forks there. One is the streaming we've been testing with, and the other has the timeline management. Those can be remerged at some point as soon as we know what is needed there exactly. On
Yeah,
the
when
remote
you
lab front,
sorry so much. When you say timeline management, this is to enforce correct timing for the frames. So it's still not in a condition where you have a bunch of frames coming through the system. We had issues with inaccurate timing, and that was cleared up with some work.
yes, that's correct. The timeline manager separates out the different functions of Dialogus into different threads. And the one that's responsible for sending transmit frames down to IIO so it can get shuffled into the FPGA through DMA um, is pretty much nailed down to a 40 millisecond timer driven by the hardware. So it's almost impossible for that to get out of sync um, and do things in the wrong order, stack up 2 frames where there should have been 1 or 0 where there should have been 1. These are all things that can happen in the old configuration. Um, and we'll need that eventually. At the moment, we're a little bit more fast and loose with timing and hoping to start seeing some valid data, and then we'll be in a position to nail down the timing. That I don't guess there's anything stopping me from going ahead and unifying those 2 threads.
Yeah.
That'll be interesting. The timeline manager set of mods is very focused on transmit, but there's nothing stopping that from being generalized to include receive. There'll just be another thread or two probably to handle that in the same sort of way. On the remote lab front, we've been having really good success with the new VM configuration, the My Melody. It seems to be much faster than anything we've had before on remote labs, with the simple expedient of it, dedicating a 4 TB SSD into the VM. Um, we have that hardware installed in the old uh, server, the one that is San Diego. Um, I'll just have to arrange some downtime to configure it because I have to reboot to configure how the SSDs are allocated. So that could happen pretty soon if we can find a time when it's not being used for something else. Um, what else do I need to talk about?
Well, we have installed a number of tools to My Melody, and thank you so much for helping make that happen and to make it as easy as possible. And all of these new tools are helping achieve some things that we're doing for Future GEO. So the uh, Future GEO project. This is a ESA program and funded. AMSAT DL is kind of spearheading and organizing the work. And what we've kind of done is to take our existing like opulent voice modem work on the Pluto, and since there's a call for prototypes, that we can go ahead and start working on integrating the Haifuraiya or the space segment side with the work that we're doing for essentially the terrestrial modem. So what we've been talking about over the past month or two has been how would you use opulent voice in a terrestrial repeater system? So how would you do point-to-point link? How would you do a repeater system with the we have a demo over the internet repeater system that's been set up and spread around. What you do is you take your interlocutor, you point it to the essentially the repeater demo or repeater demonstration situation, and over the internet you can see how it would feel, how it would look and sound, which that's kind of the point of all of this, is the really good voice quality and the fact that keyboard and data and control is all integrated, that you don't have to switch to clunky packet mode, that it all just works and it's familiar to anybody that uses any sort of modern communications. And so all of that has been going on, and we've made lots of progress. So now is the time where we take that and we make a prototype that includes the RF link, that includes a space segment, that includes the polyphase filter approach to the receiver side, the multi-phase stuff, that all of this on a much larger FPGA in the space segment happens. And critically, that the work that Aaron has been talking about for a while, the DVB encoder downlink, where all of this uplink channels are multiplexed, put together, quality of service is ensured, all sorts of things are done for you to make it fun to use. And all of that is then we put it all together into DVB frames, and it goes through the encoder down the downlink on a 10 gigahertz downlink. So we're assuming 5 gigahertz up, 10 down, or it could be 10 up, 24 down, or it could be 47, 47, or whatever. Those things are also stuff that we're actively talking about, making sure that the microwave side of the RF link is taken care of. But as far as the FPGA is concerned, what we need to do now is make sure that the Pluto SDR, which is our uplink or a ground station transmitter, is rock solid. That's coming together and has been what we've been working on for a while. And over the past couple of days, we've ported that code base, the VHDL code base, to the ZCU 102. This is an UltraScale Plus FPGA. And what motivated this, or what kind of pushed it along, was that adding the framer, deframer, and going to standard AXI stream on the Pluto pushed it over the edge of the 7010. The design can't fit without dumping things that we really like the PRBS self-test, or cutting out large chunks of it. So kind of a toss-up that could even be fully compressed. Tried to use attributes to try to get all of the buffers for all the framing, deframing to actually go to block RAM. It can't do it because we are actually having to do some sophisticated things with reading and writing. So that puts it out of the category of stuff that can just be offloaded to BRAM without somebody far more competent than me getting in there and digging into the guts. And, when you start handling intestines, it's a little weird. So in order to keep it straightforward and for have the source code be platform independent and readable by a human, we're just going to have to go ahead and say that the Pluto handles the transmit, it frames, it won't deframe, and that will all fit. So we're just doing our original plan. The Pluto is the transmitter. It's the ground station transmitter. Transmits up to Haifuraiya. It's received, and then you get a downlink in DVB-S2. And, as I said, Aaron's done a lot of work here, so that you would receive it on your 10 gigahertz receiver on the ground, which is relatively inexpensive. This is stuff that people are implementing with an LNB and a dish and a filter, and it's pretty straightforward. So we're good. And all of this will help us show an actual prototype end to end over the air for Future GEO, or for anybody that's interested in things like Future GEO. So 2026 is where Future GEO would really like to see prototypes demonstrated. This would be on the more towards the advanced or regenerative all digital microwave system. The Future GEO program wants to see everything from just a linear transponder all the way up to what we're doing. So we're happy to show up and show our work, and we'll be one of the 3 or 4 different proposals for this particular program. And all of this will be available to anybody that wants to use it. So that's what's been happening over the past week. It is kind of a big deal because we're going to have, up to now, we've been working with Pluto MSK repository, which is targeted the Pluto, which was doing everything, transceiver. Now that's going to stay the same. That's the sort of the root base of the project. We'll have a transmitter. We have to call it something, but that's going to be based on Pluto MSK and the work that's been done to. It's in a branch of Pluto MSK, the branch for Haifuraiya or for the space segment. That's going to need its own repo because it has to be in order to put it onto the ZCU 102. We're going to go ahead and use Petalinux like we have in the past. If it looks like maybe OpenCPI might be a better way of getting around the intense amount of configuration management required for getting this to work. And I talk at length about that. If OpenCPI is a better way forward, then we'll do that. So that's the status for the lab work and for Opulent Voice. The modem looks really good. The folks that have worked on this up until now, thank you so much. It's a real winner. I think we're going to just continue to move forward. Going back to the modem design, there is at least one variant on the modem design that we're considering. So we have a very traditional old school design with 2 different Costas loops and 2 different tones. This dates all the way back to Hodgart and Massey. We can step forward and have a single basically a single NCO or a single oscillator design. So if you're interested in this sort of stuff or want to learn more about it, that's actively going on. Okay, and I think that's it. That actually leaped forward in the agenda to the Opulent Voice design with frame replace and route challenges. Yeah, we are at 21,000 lookup tables used out of 17,000. That is almost all of that is because of the additional buffers from the framer and the deframer, which cannot be assigned to block RAM just with an attribute. So the additional logic pushes us well over the limit of the 7010. We do have if you've been listening to these meetups, you know that we have some super Plutos, which have a 7020. That is yet another way forward because all this design does fit into the Pluto or the variant of the Pluto hardware. People are calling it like a super Pluto or the clones that are out there with the 7020 FPGA or Zinc chip. This design would fit easily within a 7020. They're not documented very well. It's not clear that we could just make the firmware and put it onto these devices. But we'll go ahead and try and report back. And that would be another way for somebody to get a relatively inexpensive SDR and just have the full design, the whole transceiver for Opulent Voice in it. So we haven't forgotten about that. But the challenge there is that they are in some cases they almost come undocumented completely. All right, the other item on the agenda, I've touched a lot on Future GEO already. The only other additional thing that I have is that the rest of this year, 2025, is supposed to be for documenting lessons learned from the QO 100 GEO amateur satellite. So that's ongoing. We've been part of the process of documenting and talking about it. So for the year of 2026, and 2026 is when Future GEO would like to see demonstrations and prototypes of the sorts of designs that we might want to see for amateur GEO or HEO or any other interesting orbits, higher orbits that want to see that actual prototypes. So our focus has always been kind of in this direction. We really believe in demonstrating and prototyping, and it doesn't work until it works over the air. So, hey, let's just use this project as a organizing principle and bring out more and more designs and show off things like OpenCPI and all of the open source VHDL that we have, our ideas about things that are delightful to use and modern sort of innovative ways of doing things. So that's the report for this week. All right.
Is there any specific dates on like having those demonstration, or is it just as soon as possible, or?
Oh yeah, that's a really, really good question. So the one workshop Well, the most recent workshop, I should be fair, for Future GEO was just this past AMSAT DL symposium. I would expect, and I asked at the symposium when the next workshop was going to be held. Now, the workshops are
Okay.
more for workshopping, talking about things and prioritizing and all that. And so we do have a memo about the workshop in the repo, and that will go out in the next newsletter that talks about what happened at the workshop and what sort of things were decided and what ESA told us, which was
Mhm.
basically. The rest of the year is documenting what has been done with QO100 and other HEO projects and developing community relationships with organizations like us. So we're included. And then 2026 is they're looking for prototypes. They did not have anything more specific than that in terms of
Okay.
deadlines. And the question when I asked, when's the next workshop, was we're working on it. So I would expect that probably next autumn, there will be
Mhm.
another pretty big workshop opportunity in the EU, probably at the AMSAT DL symposium for 2026. That's my guess, but that's
Yeah.
just a guess. I think that that will probably happen, and they'll announce these things well in advance. So my approach to this sort of thing is, since we're already kind of working really hard and believe in this already, that we should just use this to the cycle. Yes, we should focus on prototypes and to show off things and to coordinate and to publish and to, if we have our own video walkthroughs, or if we keep doing this every week, that we will have plenty to show and point to the ESA and say, yes, this is the design for amateur radio. This is what we should have in space. This is what you should be doing. This shows off the power of open source digital communications and microwave. So I know that's not really the best. Best answer would be, oh yes, they would like on September 15th to have like a deadline for essentially for prototype designs. But my gut is this as soon as possible. We should just go ahead and keep
Yeah.
doing what we're
Yeah.
doing and pick natural milestones to kind of talk about and say, okay, well, here's where we have an end-to-end test for this, or here's where we have a uplink full with with external data working on AXI would be great because we've
Mhm.
had some issues there. Or the downlink, here's a full downlink over, say,
Yeah.
OpenCPI that is actually like what you expect, those sorts of things. So, yeah, I think as soon as possible, but like a reasonable soon as possible, I
Yeah.
think work in. And then as soon as I hear anything back from any of the folks at ESA or AMSAT DL, because they're the community organizer that's named. The ESA picked AMSAT DL to review proposals. So they're the reviewers. They're great to work with, and I'm very confident that we'll get all of the stuff in front of them, and they'll be able to review and represent it to the ESA. Uh, the ESA and all of us together are going to have to organize launches. There's not a launch scheduled for a GEO amateur satellite mission yet. However, the ESA very serious about this and would like a follow-up to QO100. And that came through very clear during this meeting and the previous meetings. So we have a real opportunity to be on a launch and get some support from integrators and companies. And we have an opportunity to reach out to anybody that we know in the industry and try to get them involved in this as well. Multiple satellites, multiple missions that are all kind of doing the similar or same thing would be fantastic to kind of move things forward for digital signal processing and open source in space. So that's what I know today.
Thanks.
Oh, you bet. And then I wanted to welcome Matthias Graino, I think. Graino. Welcome to the meeting and happy to see you here.
Thanks.
All right. And another pretty significant effort, and Thomas and Rick are both here, I think, in relation to it, is Earth-Venus-Earth communications. And we had an attempt in 2025 for the most recent inferior conjunction, which is when Venus gets the closest to Earth in its orbit. And there's another opportunity in October of 2026. So in terms of 2026, we need to focus on the prototypes and some collaboration progress. We already have a pretty extensive link analysis that we have done, and we think we have a pretty good understanding of the digital signal processing challenges. We have some excellent results from 2025. So the question for moving forward is if there is any consensus on frequency, to pick a frequency or two or three. Doesn't matter, but if there's any consensus on like these are the frequencies that we need to prepare for, because it's literally just a line in the Python, and if there's any other issues for the attempt. So what we're expecting is to be able to produce SIGMF files for transmit that and a justification for like you need to try this ZADOF2 or this OTFS or this has yet to be named file. So right now, I think what we need is some consensus on those sorts of things, and whether or not sites are committed to going ahead and doing digital sort of transmit style test. So I'll turn it over to Thomas.
Yeah, so for our side, Dwingelo, we have not really started on this project yet. I brought it up in one of the project meetings a while back, just as an idea to do this again. I bet there will be enough people interested to pull this off, but yeah, the question is, how are we going to do it this time? We learned a few lessons from the previous one. And what else do we want to do? Because just repeating it would, yeah, well, it's still interesting, but we want to see if we can do more. Of course, we had much more on our list that day, which we could not proceed with because the amplifier failed after 4 transmits. So we can certainly work down that list, but realistically, seeing the returns we had on 23 centimeters, there's not a whole lot more than detecting your signal. If you do this for a very long time, you might communicate a few bits, but yeah, with that setup, not a whole lot more than that. The only option to maybe increase the link budget a bit is to go to 13 centimeters or to 2.3 gigahertz. That's not simple for us. We don't have a good horn at the moment to do this. It's not in the focus. So we basically would have to build something completely for that project. It might overlap a little bit with the Artemis project for us because we will be following Artemis 2 on S-band. So maybe we can combine the two and make a new feed for Artemis that later on can be used to transmit as well for Venus. That is an option. It would give you a bit more budget. I don't have the numbers in my head right now, but it's probably a few dB. On the other hand, the Doppler spread increases too, so you lose as well. So the question is, do you really gain enough to make it worth all of this? That probably would be a good first investigation. And I think realistically, it's choosing between those two. We had 1 kilowatt on 23 centimeters last time. I don't think it's realistic that you're going to get a whole lot more than that, either on 13 or on 23 centimeters. So the question is a little bit, what do we really want to achieve? And if I remember from all Pete's analysis, but yeah, he would have to speak for himself, of course. I think in the end, he kind of came to the conclusion there's not a whole lot you can do in smart things. It's just what it is. He had a lot of really nice ideas that might maybe even work on the moon because the round trip time is much shorter, so you can actually respond to what you see. But here, yeah, the round trip time is so long, I don't think that works there. But it would be definitely interesting to have Pete's opinion on this topic as well.
Yeah, and I would not presume to speak entirely for him. What you're referencing is his investigations into delay Doppler channels, and these like OFDM, OT and OTFS, both of them they get a lot of leverage off of being able to have a sort of a channel sense that's built into these protocols. So OFDM and OTFS both will send out essentially what we would probably call pilot tones, and those will give you a lot of visibility into the state of the channel. And what this does is it allows you to then modify your link. You can actually modify the modulation in order to take advantage of the actual conditions on the link. So when we're talking about EME or terrestrial, let's just focus on terrestrial. When you have a terrestrial OFDM link, like what we have all the time in cellular, the delay of through the channel, the latency is pretty short, and the information that you get is valuable. So this is an age of information sort of question, which is a whole field of study in engineering. Like if you get back the notification that someone's waiting for you at the train station, that's not going to be much value to you if it's 3 days from now and you get that notification. If somebody's waiting for you right now, then that's value. So when we talk about age of information and channel information, channel conditions change pretty rapidly because of physics. And so what Pete was kind of digging into was, well, we get all of this amazing information, and OFDM works really well for cellular because we are able to tell what the channel's doing. Can we do that for Eve, for Venus? And the answer is, oh no, maybe not. So it gives you some traction, but that traction is not reliable. It might be great, it might be zero. We don't really know. It could be great. What we should do is really continue to look at EME because that's different than terrestrial. We know it works for terrestrial. Does it work for EME? If it works for EME, then gosh, well, can we extend this? Maybe the channel doesn't vary enough. It varies so slowly that we can then use the information to really get a lot of gain. But yes, what we're talking about, because of the Doppler spread, even though the Doppler spread wasn't as bad as we originally thought, it's still the erosion, if you want to look at it that way, in your budget is big. And this takes out all of the digital ham modes, in some cases by like a 10 dB margin, like it's not even close. So trying to get any traction on this, when you're limited in time and you're limited in frequency and you're limited this and limited that, there is actually a very dim path through, but everything has to be pretty perfect. So what we're doing is we're trying to define these limits and to show, like, is there any possible way to just get like you said, it's like in this small number of bits. This is not this is not going to be a big channel. Everything has to work reliably and right. And if we can get any traction with the way that we construct the modulation, then that we should try it. But it is a very long shot. So I think what we will do is try to answer the questions that you've raised and to define things very clearly so that people can see the actual challenge, to draw some good graphics so that people can intuitively grasp it. And then just put it back out there to see if anybody with any insight or any other ideas will come forward. So if you're willing to try it, what we'll do is we'll just focus on being able to provide the documentation and the analysis and the results and then the files. If there's any possible way to kind of help combine it with the Artemis attempts and to reuse the hardware for Eve, then we're 100% happy to fall in and support that and to make it work for you guys.
So yeah, two more things on that. First, I think it would be useful if we evaluate what is the difference between 23 centimeters and 13 centimeters. So we don't need the absolute link budget for 13 centimeters. We just need the diff with 23 centimeters, because then we have all the same unknowns, but at least we know how many dB it's better than what we currently have. Because I just realized also the reflection on Venus is lower at 13 centimeters. So we need to be careful that we don't go a very difficult path that then doesn't give us a whole lot of benefit.
Right.
And the other thing is, just as with the previous Eve, practicing on the moon works really good. And actually the whole project we have going on with moon bounces, that was started also as a test for Venus, actually is more interesting than the whole Venus project itself. Yeah. So there's a lot we can do in the meantime. And The thing we also learned, and actually we prevented that, is that if you wait with your complete setup for the EVE and then something fails, then you lose everything. So you better do a lot of testing before that time, so you actually know what's going to happen. But
Yeah, the
yeah,
EM.
but we still have time to think further about these things, get the right people involved, see what is possible, and actually getting some actual bits back and forth to Venus would, I think, be a great step forward. We can do that.
That's the motivation. That's exciting. But I think nobody would disagree that it's a very challenging link. This is not easy at all. And yeah, the EME results that you've shared and are completely lovely. This is really cool. And yeah, we can do that throughout. So I just want to thank you very much for all of the wonderful opportunities that you've enabled and you know just all the steps forward and all the different directions. It's been really great. So we'll do our best to kind of spread the word about the EME work and to emphasize and highlight the value there too. Because a lot of people associate EME with just, it's contacts, just a number in a ledger or a log. But there's an awful lot of cool science that can be done. And, I think we're seeing it.
Yeah, and if we find more people who are interested in this, apart from Pete, of course, then we have the data from the EVE in 25, which is public available, but I can point people to it and walk them through it. And we have these moon bounces regularly now. So if there's things to test, just give it to me and we bounce it off the moon and you have nice data. It's really as easy as this.
Wonderful. Yeah, thank you. I think we'll be taking full advantage of that moving forward. And yeah, no, just thank you so much. Okay, let's see. And I think that leaves Rick. Is there anything in particular about EVE 2026 that you want to talk about?
Yes, a number of things. First of all, the Deep Space Exploration Society's website has been woefully inadequate in communicating information on this and similar subjects. So I am now taking partial responsibility for that, and I'm editing the website as we speak, literally. And there's two new sections on the website. One is called Projects, and under Projects is EVE, one of our 7 ongoing projects. Most people don't realize that we have that many projects ongoing and we have room for more. And some of them are overlapping projects. For instance, EVE, we've now instituted EAE. Now, you might ask, what is A? The Apophis asteroid. We're planning a project to bounce signals off of that, which will be the largest near-Earth object to come through in 2029. So it's a ways out, but we're investigating bouncing signals off the asteroid. We're not sure if we can do it because it's a much smaller target, although it's much, much, much closer, but it's also moving quite rapidly. So we're just looking into that project now as whether we can track it, and if so, can we bounce signals off of it in the short time it will be coming awfully close to Earth. It would be very interesting. And there are 7 ongoing projects. I encourage people to look at them. We also have a new section under science called Deep Space Observations, not relevant to this conversation, but that's where we're going to be posting our pulsar, magnetar, and other deep space project results that have been reported on in our engineering meetings, but have not been published as such. And so as far as EVE is concerned, there is a page there for EVE now, which I just put up yesterday. It's a placeholder, and I will very soon be implementing a combination of uh, subpages that describe the ongoing work for EVE. Some of our own members didn't realize how many sub-teams are working on this project. A team of 3 people involved in improving the steering of the dish, another team for fundraising, another team obviously for hardware design, your group uh, doing some fine work. All of those teams need to be recognized. What are they doing? How are they progressing? What reports have they put out? What hardware designs are available, and what software has been done, uh, which may be either the software itself, maybe on the web page, or links to other sources like yours, so that everyone's ongoing work in almost real time will be posted there. That's something we've just failed to do adequately so far, is publish our work. The
Oh, that's
work
important.
is, yeah, we've written it. I mean, we've got reports and we've got proposals and all kinds of things, but we haven't put them up for public viewing and review, and that's what I'm doing. Secondly, uh, it's a little, it's a few hours premature, but there's a board meeting this evening that will slightly restructure uh, our EVE project, and the board is expected to appoint a overall project manager to lead these subgroups of hardware, software, steering, whatever groups. And I expect that will be myself. Will probably be the project leader for EVE. We are very actively pursuing EVE 26. We already have a design. The proposed hardware design right now is not exactly what we thought it would be. I think it might be what we need if we can find a way to put it together. We're looking at not making a decision on which band is better, but rather erecting a dual band feed with dual transmitters, both 1500 watts output, one for each band, switchable by software, and obviously dual LNAs and receiver paths, so that we can switch at a moment's notice between frequency, at least one frequency on each band. Hopefully that frequency will be coordinated with any other sites in the world, whether they be in Europe or Australia or wherever, that we can find frequencies in each band that are satisfactory to everybody. But in the meantime, we're thinking of a dual band 1500 watt system. And we're in the process of getting it built now. That is, we're not waiting till the last minute like we did before. So while Thomas lost a transmitter, we lost an LNA, and we weren't on the same frequency anyway. We're on opposite ends of the band, so we couldn't hear each other. We're going to be much more coordinated this time, and absolutely we're going to want to test not only our hardware, but hopefully protocol because our goal is not to hear reflections from Venus. Our goal is to communicate. So we need a protocol and a modulation system that has the potential to at least exchange call signs. That would be ideal. That says, yes, I heard you. Now, we'll be satisfied with a one-way communications. Some of the potential participants are going to be receive only. Some will be able to transmit. If we can get a two-way communication, that would be phenomenal. If we get a one-way communication, that is far better than just a reflection. So we're pretty excited. We think we can do much better than last time. We've learned a lot also, a great deal on every aspect of the project, from hardware to software to team coordination to publications, everything. We've learned many mistakes that we don't intend to repeat. And is that all I have in my notes? Yes, I think so. Other than, yeah, that's, I think that the near term will be to try to get some EME uh, work going. And the big problem with the EME is because it's so close, we can't really listen to ourselves if we're emulating what we're going to do with Venus. So we need to have somebody else to talk to, because we're talking these long delays from Venus that we want to use with very slow modulation. So it would take longer to send our call sign or anything useful than the round trip time from the moon. So we'll definitely need a partner or two to be listening to our signals and vice versa. And we're looking forward to putting a real communication protocol on that signal and see what we can do. We can almost do that today. So that's where we are.
Okay, well, there's a good amount that's been published and talked about potential modulations, and I would hesitate to call it a protocol, but it could be turned into one. But in terms of like the modulating the information correctly in order to get the most out of the link, that's what we do and what's in the documents and on articles. So that's what we're putting together. As long as you can play a SIGMF file, I think that we can, keep moving forward with the experiments.
That's one of the first things I would like to see us do is try to play the SIGMF file right away. I don't see any reason why we have to delay doing that. We have adequate hardware for that now.
Okay. All right. Any comments or advice for Rick?
Sounds good.
Yeah, sounds good.
I'm excited about the Apophis work since I was sort of I think I brought that to your attention the last time we met, and so I'm really glad to hear that that's going to be an attempt. Looking forward to that.
Well, it's right around the corner. We have to rush on that one, 2029, but we do need to answer some basic questions. So you might take a look at the web page that I put up for that project and send me any comments, because that's just a placeholder web page right now. And I'm gonna whatever information I collect, I want to publish. I'm looking at the website, at fixing our website so that it becomes an anchor for all the other places where things are. We got stuff, emails going on in Group IO and in this place and that place. You got GitHub for certain software developments, but our web page is going to point to all those things. It'll be the anchor for the projects.
Okay, very good.
I was just doing a quick calculation on that asteroid, and it should be quite easy actually to bounce something off it.
I think
Also, I would
maybe-
assume by the time it's so close that there is really good trajectory for it. At least I hope there is really good trajectory
Well,
for it by then.
It's either going to be
So-
really good or really bad.
Well,
If we're off by a
considering
tiny fraction, it could be not so good.
Yeah, no,
for somebody, yeah. So
Yeah,
I'm sure the trajectory is pretty good right now, actually, because I mean, if they can predict this far ahead, several years, that it's going to get within within the Clark belt.
Yeah, no, it's going to be a
below
big,
below
fast
20,000 miles. Yeah,
Yeah.
I mean that's not even close. That's bullseye type of
Yeah.
accuracy.
Yeah.
So
I'm just
so
a
I
little
think
worried that they might be off by a fraction, tiny fraction.
well for years that was the worry. For years they thought, well, I mean that thing is what, 500 feet across. I mean that would put a mighty big hole in the ground. I mean, if you look at some of the like even the Chelyabinsk, the one that went over Russia several years ago, and that was much smaller. Look what potentially that did, and the detonation up at like 20 kilometers up or something, and it
Yeah.
you know and it was incredible. It's just the impact. It was megatons of power. So 500 feet across, coming in at, I don't know, gosh, whatever that is, 30,000 miles an hour or something. That would be a huge impact. But I'm sure that this thing will be possible to locate and work on approach and on receding.
Yeah.
Um,
Neat.
yeah. So you definitely have plenty of time.
Yeah,
Yeah.
and I think the challenge here is not just to bounce something off it, but to actually make an image of it in radio.
Yeah.
Oh,
That'd be
yeah.
awesome.
There you
Yeah,
go.
well, I'm sure you and Goldstone and Greenbank are going to be doing about the same thing, maybe with 100 meters, the
Maybe
100 meter dish out in Greenbank. That's going to make I'm sure they'll be able to
Yeah.
see pebbles on it.
I think we only need to receive. You probably get a lot of signal if you just point at it.
Yeah, I think you will.
Absolutely.
No, this will be really good. And thank you so much, Adrian. You flagged that last week, and I think that you'll see continuing investigation. We'll try to track it. Pretty sure that based on the libraries that we have in the link analysis, they include orbital stuff for this. So we could probably just have a case for Apophis and include it.
That's
There's a lot that we don't
that's why I
know
mentioned
because
it.
you don't know about
So-
the reflectivity, but it's really going to be very interesting. And yeah, thank you so much, Adrian, for bringing it up.
Well,
we
I
have
think
time.
as a general project, I mean, Apophis just came to mind because it's big and very close, very close. But there's these other asteroids that approach, uh, maybe not as close, and they might actually and certainly come by further than one lunar distance. So those could possibly be. I'm not sure anything that's coming up soon, but it could possibly be. Targets for simulation for the Eve.
Cool.
I mean, something. It'd be small, but it'd be a heck of a lot closer than Venus, but further out than the Moon. So,
Yeah,
because it'd be.
if you see anything in particular, just pass it along, and we'll dig in.
I'll keep my eyes open. I'm not aware of anything specifically, but on a regular basis. I mean, back when Arecibo was still around,
Yeah.
between Arecibo and Goldstone, the imaging has been done on a regular basis for many of these asteroids that are near Earth orbits.
Cool.
But
All right, yeah, thanks. We'll absolutely keep track of this. Yeah, if there's anything that you see that you think we need to know about, let us know. And
I'll definitely pop in and pass it along. Yeah, and I'm marveled gosh, I mean the transmitter now that Rick is describing, uh, my goodness, 1,500 watts and 13 centimeters also, and besides the 23, uh, that's some gear getting out 1.5 kilowatts on 13 centimeters. That's I'm not sure how many transmitters are going to be put in parallel for that, but
It's
that
not that
sounds.
hard. Broadcast radio, TV does it every day. They take a whole bunch of moderately powered units and combine them. And that's what we're planning to do because you can't just buy a big block of power for that van. So we're going to take as many, whatever, 200, 300 watt amplifiers as it takes to get there. And we'll mount them in the pedestal of the dish and put low loss coax the last few feet up, and we'll get it done. It's just, it may cost a lot of money, but we'll get it done.
Cool. All right. Well, it sounds like a plan. I think moving forward, this will be good to focus on. We'll just continue to focus on the DSP, looking at the different techniques that we have that we're aware of. We'll continue to circulate this for open source review and to just keep showing the work through the link analysis, and we'll just keep moving forward. So we'll just assume both bands are possible, and keep it published. And so for the last few minutes, Matthias, if you have anything that you wanted to know more about or wanted to share, you're welcome to take the floor.
Okay, thank you. No, it's my English is very basic, sorry, but super interesting. I want to listen. I follow all the work of the ORI, Open Research Institute. You send us the Lime SDR Mini.
Yeah.
My actual call sign is Lima Uniform 4 Bravo Alpha, but my ex call sign is Lima Uniform 9 Charlie Bravo Lima, and you send us the Lime, so we use it to the ground station for low Earth orbit. So thank for that. And no, only want to listen and so where are you working? The interesting project that you are forward.
Well, thank you so much. And please let us know if we can do anything else. So happy to hear that the Lime is useful and in a ground station. And it's really nice to hear from you again. So you're welcome anytime. And just let us know how we can help, and we'll keep doing what we're doing.
Thank you.
You bet. All right. And before we close, any last comments or questions or anything that anybody needs?
You want to stay after?
Yeah, I can. I'm available for office hours today. Looking forward for the next month. October is one of our busier presentation months. So we will be at PacificCon talking about artificial intelligence. If you check out our AI channel, you can see that there's been a lot of discussion there. And we still are looking forward to our artificially intelligent RTTY receiver article coming out in QEX. It's been scheduled for kind of a while, and we are very interested in that coming out because that was a really neat batch of work. We have a lot of other stuff in AI going on. We'll be able to talk about that at PacificCon. We will also be presenting to the AMSAT UK symposium coming right up this weekend. It will be a similar presentation to the one at AMSAT DL that talks about in general what ORI does and our Haifuraiya and opulent voice work, including all of the stuff that we've done since we got back from Germany. Another presentation coming up on the low radiation resistance high frequency antenna project that we did. That's in a couple of weeks on Zoom, and we'll be able to take that presentation and put it on our YouTube. And that concludes October for lots of presentations. And then looking forward to November and December, that's where we start working more in the lab. And then we'll pick back up with a heavier presentation schedule in next spring. That's the way it usually goes. So that's our schedule for the rest of the, looking forward to the rest of the year. All right, so thank you, everybody. This is great to hear from all of you. Thank you so much for all of your hard work. We do lots of ambitious, difficult things. Cannot do it without you and the support of the community. And we will be back next week, if not before. Please join us on Slack and on our mailing list and contribute to our repositories on GitHub. All right, thanks, everybody.